Hello, this example is from the last video about a ball being thrown upward. If you remember from the last video, the height of the ball above the ground was given by this table below. This is the same table as the last video. In this video, we're going to use this table to get the best estimate of the instantaneous velocity at t equals 2 seconds. And we did this in the last video by looking at the average velocity from 2 to 3 seconds. And we looked at the change of h over the change of time. So it was h of 3 minus h of 2 over 3 minus 2. So we just looked at the 162 minus 142 over 1, which was 20 feet per second. And we got this by using d equals rt. We're solving for r, d over t, where d was the height. So that's what we did last time. We also used this 20 feet per second as our instantaneous velocity. So now in this video, we want to get the best estimate. See if we can get a better estimate than 20 feet per second, because a lot can happen in 1 second. And we want to use this table. Yes, if we had more data, we could get a better estimate. If we had the timestamps between 2 and 3 seconds, maybe 2.5, maybe 2.1, we can, this change in time would be now only a half a second, or a tenth of a second, or even less, a hundredth of a second. We would get better estimates. But we don't have that in this table. So what I'm going to do is I'm going to look at this left-hand average instead of the right. What is the average velocity happening right before 2 to 3 seconds, between 1 and 2 seconds? So I'm going to do the same thing we did here, but now I'm going to look at h of 2 minus h of 1 over 2 minus 1. And what do we get? 142 minus 90 all over, well, this would just be 1. So that would be 52 feet per second, which is a lot different. So obviously the ball is slowing down as you throw the ball upward. So at the beginning, between 1 and 2 seconds, it was going at 52 feet per second. And the next second, from 2 to 3 seconds, it was going to 20 feet per second. So there's a lot of difference there. So what I'm going to do to get a better estimate than 20 feet per second is I know that the instantaneous velocity has to be somewhere in between 20 feet per second and 52 feet per second. So what am I going to do to find that instantaneous velocity is I'm going to look at the average. And how do we find the average? Is we going to add the two velocities together and divide by 2. So what would that give us? 72 over 2, which is 36 feet per second. That is about the best we can do with this data. I know that 36 feet per second might not be the exact instantaneous velocity, but it's our best estimate because I know that the exact estimate is somewhere between the 20 and the 52.